Our objectives today: number 1, complete your data table. Number 2, use scientific notation to fill it in. Number 3, discover what a significant figure is and work with accuracy. Let's think about this. We're talking about some really huge objects. If we were to look at this galaxy, the diameter of this galaxy is probably 100,000 light years. If we were to convert that into kilometers, that'd even be a bigger number. We could write this as 1, 2, 3, 4, 5, 10 to the 5 light years. When we're talking about the objects, there are millions of them everywhere throughout the universe. We have stars, galaxies, and each galaxy is full of more stars, and even there's another galaxy back here, and the distances between these could be 18 billion light years. It's really hard to judge distance. Here's another example. Anything you see with a plus sign in this picture, it's called the Hubble Deep Field. It's a star. Everything else is a galaxy. What kind of distances are we talking about here? How big a numbers are these that we're working with? Let's take this number for example, 18 billion. And if we didn't have so many zeros, it'd be even harder to work with, but let's rewrite it in scientific notation. So we take 18, we want our decimal point right there. So we're going to end up with 1.8 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the power of 10. Do you see what we did? We just moved our decimal point that was over here all along and moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, looks like 11 spaces. So we should change this to 11. And that's an easier way to write that number, isn't it? You don't have to write so many zeros. It's also easier to add, subtract, multiply, and divide. Now let's talk about light speed. Here we have it written in scientific notation, 3 times 10 to the 5 kilometers per second. Here we have it written in miles per hour, not in scientific notation. Miles per second, excuse me, not hours. So that MPS is miles per second. 186,282.397 miles per second. Here's the speed of light in meters per second, not miles per second, so that's meters. If we were to just read this number, it's 299,792,458. If we wanted to convert it to scientific notation, we're going to need our decimal point moved to there. Right now, it's right there. So we're going to move it 1, 2, 3, 4, 5, 6, 7, 8 spaces. So we know that's going to be 10 times to the power of 8. We're going to round it to the 10th place just to make it a little easier to work with. So that would turn the 2 into a 3, right? Because 9 would round up to 10. So it becomes 3.0 times 10 to the 8 meters per second. Here's another big number. This one's already in scientific notation, and you're going to need this to complete your assignments. 1 light year equals 9.4605284 times 10 to the 12th. That means if we're going to fix this number so that's not in scientific notation, we need to move that decimal point to the right 12 places. Okay? But we're not going to do that right now. Why is this number not written as 9.5 times 10 to the 12th kilometers? We're talking about accuracy. They want to make sure we know that this is a very accurate number. In fact, the only digit in this number that has been rounded is the last digit, that 4. And it may have been rounded up or rounded down. We know there were some other numbers after that, but we don't know what they are because they rounded it. So this number is accurate to the last digit. If it was 9.5, what digit would it be accurate to? If it was 9 times 10 to the 12th. If it was 9.46 times 10 to the 12th, what digit would it be accurate to? So think about that. We'll talk more about that later.